Hello everyone, I am Aditya Anupam, a PhD candidate in digital media at Georgia Tech, and I'll be talking about my paper, Can Digital Games Teach Scientific Inquiry? A case of how affordances can become constraints in this video. So to begin, what is scientific inquiry? John Dewey defines scientific inquiry as the controlled or directed transformation of an indeterminate situation to one that is determinate. Hello everyone. Building on this definition, I examine four dimensions of inquiry. Problematizing refers to the fact that inquiry is not just a process of problem solving, but also problem framing. Being unbounded by subject matter means that we cannot predict the subject matter needed to resolve a new problem. Being situated means that inquiry is affected by the social position of the inquirers. Being value-laden means that inquiry is affected by values such as profit, privacy, and sustainability. Now, keeping these dimensions in mind, digital games are increasingly being used to teach scientific inquiry. And that's partly because they have three key affordances. They are procedural, evaluative, and fictional. Procedurality means being able to represent and execute conditional behaviors. This is what allows digital games to simulate processes such as modeling and data analysis as well as their contexts. Next, digital games are evaluative. That means they judge a player's performance based on a set of predetermined criteria. This is useful for learning inquiry because it lets players get continuous feedback on their progress. Are they doing inquiry well or not? Finally, digital games are fictional. That means that game worlds exist separately from the real world. This is useful because it allows games to distance students from real risks and responsibilities as they learn and make mistakes. Now, despite these affordances, digital games often tend to frame inquiry as a problem-solving process bounded by subject matter, separable from society, and value-neutral. Given this discrepancy, can these affordances of digital games help them engage students with these four dimensions of scientific inquiry? In this paper, I examine this problem in relation to designing a digital game about solar cells. Briefly, the game that I was trying to design was a platformer-style multiplayer game called Solaria that engaged students in inquiry into solar cells. Now, the game was actually never developed and remained a design concept because of theoretical constraints that I will discuss in this video, as well as practical constraints. Now, each student in the game plays as an engineer from a different settlement, and the primary mechanic involves conversing with other characters and designing solar cells. In the image here, we see two players explore a silicon mine with exploitative working conditions. Now, the game itself did not have a definite goal. This was to promote problematization, as it allowed students to explore the open-ended environment and frame their own problems. For example, students have to decide if and how solar cells should be developed. To expand the subject matter, we tried to make situations require interdisciplinary framing. For example, students need to think about how to persuade other in-game characters about solar cells by learning about their history, politics, and culture. The background of the characters in the game also has a significant impact on players' experience, as non-player characters in the game interact differently with players from different settlements. Finally, the actions of players, such as the process of designing solar cells, requires making judgments about value, such as efficiency and justice. Now, in the process of trying to engage students with these dimensions, we became constrained by the three affordances of digital games: procedurality, evaluative, and fictional. The main problem of procedurality was that it required us to trivialize complex socio-scientific situations. It limited problematization by requiring us to quantify social issues, such as the plight of minors, which trivializes those issues. It idealizes the subject matter. So real-life solar cells can't be proceduralized without making reductive assumptions about their working. It requires us to simulate people as quantifiable aggregates of gender, race, ethnicity, and so on, which also trivializes them. And it requires us to quantify values such as justice in order to make them meaningful to the game mechanic. The main problem of the evaluative affordance was that it requires us to predetermine things that students should be determining themselves. So it constrained problematization by predetermining the criteria to judge solar cells by, such as pollution, efficiency, and cost. It constrained subject matter by predetermining the game's content and relationships. It can also perpetuate stereotypes. For example, predetermining the experiences of a female character in the game can risk perpetuating stereotypes about them. Finally, it constrained values such as sustainability by predetermining what they mean. Finally, the fictional affordance of games distances students from real risks and responsibilities which are integral to real inquiry. Fictional social problems are low stakes and may not be taken seriously by students. Subject matter applied to fictional problems may not easily transfer to real problems. Students' fictional responsibilities don't matter as much as there are no real life consequences. And similarly, values such as justice and democracy carry less weight in a fictional space than a real one. This chart summarizes all the ways in which these three affordances constrain the four dimensions of inquiry. Now, the primary limitation is that my findings cannot be generalized since I focused on just one game. And the second key limitation is that I do not examine the circumstances in which the game may be used. And that's actually the future plan for this work, where I'll explore strategies to complement digital games, such as by having students critique or redesign games. And that concludes the video. Thanks for watching.